All right, let's look at one more example. So this is the fourth example in our list. So let's say we have a matrix. This is also a 3x4 matrix. And down the columns, I have 4, 6, 3, 5, 5, 4, 9, 1, 8, -2, 12, -3. All right, and so I'm going to row reduce this. All right, and so down my columns, I get 1, 0, 0, 0, 1, 0, -4, 5, 0, 7, -6, 0. And so the question that I want us to answer about this matrix, how many vectors will be in a basis for the column space of A? All right, so if we want to consider the column space of A, the span of all of the columns of A, we know that the basis for our column space is going to correspond to the pivot column. So we just have to look, when we row reduce, we have 2 pivot columns. That tells us that there will be 2 vectors in our basis for our column space. All right, so we can write that out. A basis for the column space of A. Oh, you can't see that. So a basis for the column space of A is the 2 vectors that correspond to the pivot positions in the original matrix. So it'll be these 2. 4, 6, 3, and 5, 5, 4. This is a basis for the column space of A. All right, let's work on the basis for the null space. So the null space is a little harder to find because we actually need to find the null space. All right, so remember, for the null space, we want all the solutions. So I'll actually work this out. All the solutions for the homogeneous system. So we want to find AX equals the 0 vector. All the hard work has been done for us here. Great. So we set it equal to 0. All right, and we can solve. All right, so I'm going to set up my general solution and then write it in parametric vector form. All right, so for my general solution, I have x1, x2, x3, and x4. And I see that x1 is going to be 4x3 minus 7x4. So I see that I have 2 free variables. X2 is going to be negative 5x3 plus 6x4. And x3 and x4 are free. All right, now I'm actually going to write this in parametric vector form because it makes it easier to write out the null space. All right, so remember, the first step to do that, if you need it, will be to just write everything in one big vector. and then factor out the x3 components and factor out the x4 components. So I'm going to start with x3. So I got a 4, 5, 1, and 0. And then my x4, I got -7, 6, 0, and 1. All right, so this is the solution to the homogeneous system, AX equals 0. So that tells me that everything that's going to be a solution is going to be a linear combination of these two vectors. So that tells me exactly what my null space is. It's the span of these two vectors. Oh, I missed something. 4, 5, 1, 0, and then -7, 6, 0, 1. So this is the null space. So now that we see what the null space is, I have a question. I want to know how many vectors will form a basis for our null space. All right, because there are only two things here, and they are both linearly independent, then there are going to be two basis elements. So we can say that a basis for the null space of A is the vector 4, 5, 1, 0. That's 5. And the vector -7, 6, 0, 1. All right, because everything in the null space can be written as a linear combination of these two linearly independent vectors.